Hello everyone, good evening. So here we shall solve some JEE Mains previous year questions on the chapter gravitation. So in the very first question, it has been told that a satellite of 10 power 3 kg mass is revolving in circular orbit of radius 2r. If 10 power 4 r by 6 full energy is supplied to the satellite, it would revolve in a new circular orbit of radius how much? So it is revolving in a circle of radius 2r. Now we know that the total energy that is given as it is minus gm m by r minus gm by 2r. This way we know that orbital velocity that is given as gm by r. That means half m v naught square, which is the kinetic energy that is given as gm m by 2r. And the potential energy that is given as minus gm m by r. So if we add them, then we get the total mechanical energy of the revolving satellite. So therefore, is revolving radius 2r. So it means I will tell that the energy that is supplied, that is equal to the energy of the new orbit, minus the energy of the initial orbit. So the energy supplied is 10 power 4 r by 6 joule. That is equal to the new energy that is minus gm m by 2 into r dash minus of the initial energy that is minus gm m by 2 into 2r, which is 4r. It means that is 10 power 4 r by 6, that is equal to minus g into r is the radius of the earth. M is 10 power 3, so 10 power 3 into mass of the earth. So G has been told at this time, so G is equal to Gm by r square. So Gm I can tell that is equal to Gr square. Is G into m by 2 into r dash plus that is G into 10 power 3 into m by 4r. So now 2 I can cancel out, 2 to the 4, 2 to the 6. So this is 10 power 4 by 3. The 10 power 3 also I can take as common, and this I can cancel out. So this is 10 r by 3, that is equal to minus gr square by r dash plus gr square by 2r. So from here, one of the r also will get cancelled. This also will get cancelled. This 10 by 3 equals to minus g is 10 r by r dash plus g is 10 by 2, that is 5. So with 5 I can cancel out, 5 and the 5, 5 is a 10, 5 is a 10. So it means I can say that this is coming. Therefore, we got 2 by 3, that is equal to minus 2 r by r dash plus 1. So it means that 2 r by r dash that is equal to 1 minus 2 by 3, that is 1 by 3. It means 2 r by r dash that is equal to 1 by 3. It means that 2 r, you can say r dash that is equal to 6r. R dash equal to 6r. So this option B is the correct answer. Here it is told that an astronaut takes a ball of mass m from Earth to space. It's a ball of mass m from Earth to space. He throws the ball into a circular orbit around Earth, an altitude of 318.5 kilometers. So this is the height at which it is revolving circular orbit. From Earth's surface to the orbit, the change in total mechanical energy of the ball is x into okay, x into g m by 21 RE. The value of x is, take RE equal to 6370 kilometer, which is the radius of the Earth. So now, for the change in total mechanical energy, that is equal to the final total energy minus the initial total energy. The final total energy is minus Gmm by R by 2 RE by 2 R, sorry. By 2 R. Where R will be equal to RE plus H minus of, this will be, so when it is, from when it is kept on the Earth surface, then it has no kinetic energy. Therefore, the initially the energy will be minus Gmm by Ra. Therefore, the change in total mechanical energy, that is equal to Gmm by Re minus Gmm by 2R. This will be equal to Re is this. So now the height is equal to 318.5 kilometer, which is equal to Re by 20. Since y, if we do by 10, this will become 637, and that by 2, if I do, then will be 2 3 are 6, 2 1s are 2, 2 8 is 16, and is 10. So Re by 20, H is Re by 20. This will be Gmm by Re minus Gmm by 2 and 2. Re plus Re by 10, Re by 20. So this will be Gmm by Re minus Gmm by, this is 21 Re by 20. So this is 21 Re by 10. So this will be Gmm by Re into 1 minus 10 by 21. This will be 21 minus 10, that is 11. So 11 by 21 into Gmm by R. So therefore, the value of x will be 11. X is 11. So option B is the correct answer. Then here it is told two satellites A and B go around a planet in circular orbits. Two satellites A and B go around a planet in circular orbits. Go around a circular, go around two satellites A and B. And we go around the planet in circular orbits having radius 4r and r respectively. So this radius is 4r and this radius will be, this should be closer. Should be slightly closer. So this is r. This b. So its radius is orbital radius is r. For a, the orbital radius is 4r. The speed of a is 3b, then the speed of b will be how much? B matrix. Now we know that the orbital velocity is equal to root over gm by r. Root over gm by r. Root over gm by r, I can say. But r is the orbital radius. So v naught, that is inversely proportional to root r. So therefore, I can say that v dash by, so v dash is the orbital velocity of b and 3v is the orbital velocity of a. That will be equal to root over r root over r a by root over r b, which is the orbital radius of a by orbital radius of b. By the square root of orbital radius of b, so this is square root of radius of a, that is 4r, radius of b, that is r. So this is root 4, that is equal to 4. So therefore b dash will be equal to 3v into 2, that is equal to 6. So the speed of v will be 6. So option A is the correct answer. And here it is told two planets A and B having masses m1 and m2 move around the sun in circular orbits of radius of r1 and r2 radii respectively. The angular momentum of A is L and that of B is 3m. The ratio of the time period T and TB is angular momentum of A is L. That means that MA into VA into RA, that is equal to L, and MB into VB into RB, that is equal to 3. Ratio of the time period we will find out. Now MB, that is M2 into V2. Now V2 is 2 pi. V is equal to actually orbital velocity, that is 2 pi r by t. So I can say that is, which is actually equal to r. So this is 2 pi. Simply I can say that MB into 2 pi RB square by T, that is equal to 3m, and MA into 2 pi RA square by TB, TA, this TB, that is equal to M. Now therefore if you take the ratio of these two, then you will get MB RB square by TB divided by MA RA square by TA, that is equal to 3L by L, that is equal to 3. Therefore, MB, that is M2 into R2 square, RB is R2 square divided by TB, divided by m1 into r1 square by ta, that is equal to 3. So therefore, you can say that m2 by m1 to r2 square by r1 square into r2 square by r1 square into ta by tb to ta by tb, that is equal to 3. Ta by tb, that will be equal to 3 into m1 by m2, 1 by m2 into r1 by r2 whole square. Angular momentum now we can also say that we can apply the Kepler's laws. So the time period is actually, it is the square of the time period is proportional to cube of the orbital radius, which is independent, since y t is equal to, we know this know that orbital velocity, that is equal to actually u power gm by r. That m is the mass of the sun. So orbital velocity is 2 pi r by t. So it is independent of the mass of the planet. The orbital velocity is independent of the planet's masses. So basically root gm by r. So from here, if we simplify it, we will get p square is proportional to r cube. Therefore, I can say that T1 Ta by Tb whole square, that is equal to Ra cube by Rb cube. It means, therefore, simply we can say that Ta by Tb, that is equal to Ra by Rb whole power 3 by 2. The radius of the planet A, that is R1, so R1 by R2 whole power 3 by 2. So option A is the correct answer. So this is Ta by Tb. So here it is told, assuming the Earth to be a sphere of uniform mass density, a body weight 300 Newton on the surface of the Earth, how much it would weigh at R by 4 depth under surface of the Earth? And the Earth is to be a sphere of uniform density, our body weight 300 Newton on the surface of the Earth. So 300 is equal to m into g, g on the surface of the Earth. Now, g value at a depth d, the value of g, it is given as g at the depth d, that is given as g into 1 minus d by r. G into 1 minus d by r. So therefore, the new weight at the depth, new weight at the depth d, that is given as mg, that is So actual weight 300 into 1 minus d by r by 4 by r will cancel 1 by 4. So this is 300 into 1 minus 1 by 4, that is 3 by 4. So 4, 25 is 100, so 25 into 3, so 25 into 9, that is 225 Newton. So option D is the correct answer. Then it is told to project a body of mass m from Earth's surface to infinity. The required kinetic energy is. So we know that we have to give the escape velocity. So it is half mv square escape velocity, that is equal to the kinetic energy should be equal to the gravitational potential energy, which is gmm by r re. Therefore mm will get cancelled. So the kinetic energy only has been half. So gmm by re. So the required kinetic energy, that is 3. We know that Gm is equal to Gre square. So Gre square into m by re. So that is mg into re. So mg into re is the required kinetic energy, which is required. So option C is the correct answer. When it is told a satellite revolving around the planet in a stationary orbit, satellite revolving around a planet in a stationary orbit, time period of 6 hours. Mass of planet is 1/4 the mass of Earth. The radius orbit planet is. The orb, the radius of the orbit planet. Radius of geostationary orbit for Earth is 4.2 into 10 power 4 kilometer. So now, the geostationary orbit, the time period should be equal to the time period of revolution. So if time period is 24 hours and m is the mass of Earth, re is the radius of Earth, so then I can say that for that satellite, p square is proportional to r cube. Now can say that the orbital velocity, that is equal to root gm by r. So therefore, 2 by r by t, that is equal to root gm by r. So therefore, if we square that, then we get 4 pi square r square by t square, that is equal to gm by r. So t square will be equal to 4 pi square r cube by gm. T square will be equal to 4 pi square r cube by gm. T square 4 pi square by gm into r cube. So where m is the mass of the Earth here in this case. So you can say that 24 square, that is equal to 4 pi square by g into mass of the Earth into r, that is 4.2 into 10 power 4 kilometer cube. So therefore, gm into me, I can say it is 4 pi square into 4.2 into 10 power 4 cube divided by 24 square. So this will come in kilometers square per hour square. Now, for that planet, the time period of revolution of the satellite is 6 hours. The mass of the planet that is equal to 1/4 of the mass of Earth. And so the radius of the orbit of that satellite around that planet is r that we have to find out. So now therefore you can say that time period of that satellite, you can say T1 square, that is equal to 4 pi square by g into m1, which is the mass of the planet, into r cube. This r only we have to find out. So T1 square is 6 square, that is equal to 4 pi square by Em, that is equal to 4 pi square into 4.2 into 10 power 4 whole cube by 24 square into r cube. So therefore 4 pi square will get cancelled, and then here the r cube will be equal to 4.2 into 10 power 4 whole cube into 6 by 24 whole square, which will be 6 4 24, 4 16. So r cube will be equal to 4.2 into 10 power 4 whole cube by 16. It means that r will be equal to 4.2 into 10 power 4 divided by cube root of 16, in 16 power 1 by 3. 16 power 1 by 3. So now is a 9, 3, 27, 3 of 4 is a 8. Now 16 power 1 by 3, 16 cube root of 16, that we can say that will be equal to approximately 2.52. R will be equal to 4.2 divided by 2.52, approximately into 10 power 4. So this will be approximately it is 1.67, approximately 1.67 into 10 power 4 kilometers. So so here the mass of the planet, that is 1/4 of the mass of the Earth, and one is 1 by 4 in it. So this I can say this is 1 by 4 times. So I will say this is equal to 4 pi square by 1/4 of GME into R cubes. So this will become 6. This 1 by 4 will go up. This will be into 4. 4 will come. So 4 4 is 16. So we have to take 4 cube root of 4 actually. So R will be equal to 4.2 by cube root of 4 into 10 power 4 kilometers. Cube root of 4 is approximately 1.6. 1.587 approx 5.874 into 10 power 4 kilometer, which is approximately 4.2 divided by 1.5874. It's approximately 2.646 into 10 power 4 kilometer. And so R cube will be, sorry, 1 by 4 times of this. Sorry, 1 by 4 by 4 will come. This will become 64. So it will become 64, cube root of 64, which is 4. 4 will come instead of this. So R will be equal to 4.2 by 4, which is 4 ones are 4, 4 5s are 20, 1.05 into 10 power 4 kilometer. So option D is the correct answer. And here it is told if G be the gravitational constant and U be the energy density, then each of the following quantity have the dimensions as that of the U square root of U into G. So square root of U into G, so it is the energy density, which is energy by volume. So energy is mass into acceleration. Okay, so it is ml power ml square t power minus 2 divided by L cube into G, that is force into length square by mass square. Is ml t power minus 2 into L square by m square. So it will be ml cube m power minus 1 L cube t power minus 2 m power minus 1 L cube t power minus 2. So this will be m power minus 1 will get cancelled. So this will be L cube also will get cancelled. So this is L square into t power minus 4 whole power whole square. So this is L into t power minus 2 L by t square, which is ml t power minus 2 by m, I can say. Is actually force per unit mass. Force per unit mass. Option D is the correct answer. So it means that the dimension of square root of U into G is same as force per unit mass. So option D is the correct answer. Then it is told kinetic energy of a planet that is equal to gmn by 2a, so which is option 2. So A matches with 2. A matches with 2, so obviously option A is the correct answer, but still we can check. Gravitational potential energy of Sun planet system. Gravitational potential energy of the Sun planet system, that is equal to 1. So B will match with 1. And C, the total mechanical energy of the planet, that will be obviously 4, which is minus gm by 2a. Then escape energy of the at the surface of planet for unit mass object, that is g m by r. Escape on the surface of the planet for unit mass escape energy. So that is obviously gm by r. Since we know that half m v square, that should be equal to g mm by r. So for unit mass, it should be gm by r. But, m is the mass of the planet, capital M is the mass of the. So here actually it should be g into capital M by r instead of g into small m by r. So actually g will match with none of these, but if instead of small m we put capital M, then it will match with 3. Then it is told that 90 kg body placed at 2 r distance from surface of Earth experiences gravitational pull of. There is a 90 kg object, 90 kg body placed at 2 r distance from the surface of the Earth. It experiences a gravitational pull of energy. So the gravitational pull, that is force, gravitational force, that is m into g at the height h. So that will be equal to mass of the planet, that is 90 kg, into g at a height that is given as g by g r square by r plus h whole square, okay, at a height. So 90 into g into r square by r plus 2r whole square. So g at the surface, that is 10. So 90 into 10 into this will be r square by, should be 3r whole square. So that is 9 r square. R square cancel, 9 times 90. So this will be 10 into 10, that is 100 Newton. So 100 Newton is uh, the gravitational pull of that the body will experience at that height. So option C is the correct answer. It is told correct formula of height of a satellite from Earth's surface is. So there is a satellite which is kept at a height of h from the surface of the Earth, and its time period of revolution is t. The radius of the Earth is r. So then can say that the orbital velocity is root over gm by 2r, root over gm by r plus h actually. So therefore, we know that is 2 pi into r plus h by t, that time period, that is equal to root over gm by r plus h. So if we square both sides, then we will get 4 pi square into r plus h, no, 4 plus h into uh, 4 pi square into r plus h whole square into t square, that is equal to gm by r plus h. So therefore, I can say that r plus h whole cube, that is equal to gm into t square by 4 pi square. And g into mass of earth, that I can say it is equal to gr square. G is gr square. So therefore, I can say this is r plus h whole cube, that is equal to g r square t square by 4 pi square. Therefore, r plus h plus r, that will be equal to cube root of this, which is equal to t square r square g by 4 pi square whole power 1 by 3. So height will be equal to this minus r. T square r square g by 4 pi square whole power 1 by 3 minus r. So option A is the correct answer. Then it is told metal wire of uniform mass density. There is a metal wire of uniform uh, mass density having length L and mass M. Uniform mass density, so lambda is constant. Lambda is mass per unit length, that is constant throughout the length, and is bent to form a semicircular arc. Is bent to form a semicircular arc, and a particle of mass m is of mass small m is placed at the center of the arc. Placed at the center of the arc, plane is placed. The gravitational force on the particle by the varies. Gravitational force on the particle by the varies. So at this point, the net gravitational field we have to find out. So this is actually you can take a small width and go with d theta here. So its length will be r d theta. Here 2 pi. So here actually pi r length, that is equal to L. So r will be equal to L by pi of this way. So r d theta. The force of attraction will be there. This is angle theta. So this will be df is dE cos theta. If the small gravitational field is dE, this is dE cos theta, and this will be dE sin theta. So dE cos theta components will get cancelled. So only dE sin theta will remain. So the net gravitational field that will be equal to integral dE sin theta, and where theta will go from 0 to pi. Now dE that is equal to actually this is dm mass that is equal to lambda r d theta. dE is g into dm by r square into dm by r square. So E net, the net gravitational field that will be equal to 0 to pi integral g by r square into dm, that is lambda r d theta. The lambda is m by l by r square into sin theta. Therefore, the net gravitational field at the center that will be equal to is lambda g by r, lambda g by r integral sin theta d theta from 0 to pi. So therefore, the net gravitational field that will be equal to lambda g by r into integral sin theta, that is sin theta, that is minus cos theta, that will go from 0 to pi. So this will be minus lambda g by r into this will be cos pi, that is minus 1 minus of cos 0, that is this will be 2 lambda g by r. Now therefore the net gravitational force that is experienced, that is equal to the net gravitational field at the center into the mass and mass which is kept, that is smaller. So that is m into 2 lambda g by r, that is equal to 2 m g by r into lambda. Lambda is m by l, and r is equal to also r is equal to m by pi. So m by pi into m by uh, uh, pi by pi is l by pi into m by l. So this will be equal to 2 g m pi by l square. So this will be equal to, so the net force will be equal to 2 g m pi by l square. So option D is the correct answer. And here it is told a light planet is revolving around a massive star in a circular orbit of radius r with a period of revolution t. The time if the force of attraction between planet and star is proportional to r power minus 3 by 2, then choose the correct option. So we have a force that is equal to some constant k into r power minus 3 by 2, which is the gravitational force, and that will provide the necessary centripetal force, which is equal to m omega square r, m omega square r, that is equal to m omega square r, that is equal to k into r power minus 3 by 2, where k is some constant. From here you can say 2 pi by t, which is omega, so it's square, that is equal to a into r power minus 3 by 2 by n. So this will be 4 pi square by t square, that is equal to k by m into r power minus 5 by 2. So therefore t square will be equal to 4 pi square m by k into r power 5 by 2. So therefore t square, I can say t square will be proportional to r power 5 by 2. So option C is the correct answer. And here it is told if r is the radius of the earth and the acceleration due to gravity on the surface of the earth is g is equal to pi square meter per second square, then the length of the second pendulum at a height h equal to 2r from the surface of 3p. So we know that t time period of a simple pendulum that is given as 2 pi root over L by G. Now, the seconds pendulum, it means the time period is 2 seconds. Since why it takes 1 second to complete, to go from one extreme position to the other extreme position. So it means the time required to complete half the oscillation is 1 second. So the time to complete one oscillation should be 2 seconds. So therefore, length of the second pendulum, so time period is 2 seconds. 2 is equal to 2 pi into root over L by G. G is equal to G into R square plus R plus H whole square. 1 is. Therefore, here the G value on the surface at that height, that is equal to G into R square by R plus H whole square. H is 2R. So E square, so this will be G into R square by 3R whole square, that is 9R square, which is equal to G by 9. G by G by 9. G by 9, that is. So therefore, the length we have to find out. G is pi square, so it will be pi square by. So therefore, I will tell that T1 square, that is equal to 4 pi square into L by G1. Therefore, L will be equal to G1 T1 square by 4 pi square. So G1 is pi square by 9 into T1 square, it is 4 square by 4 pi square. Pi square will cancel, so that is 1 by 9 meters. So the length should be 1 by 9 meters. Option A is the correct answer. Then it is told the mass of the moon is 1 by 144 times the mass of a planet. The diameter is 110, 1 by 16 times the diameter of the planet. If the escape velocity on the planet is v, the escape velocity on the moon will be. So we have a planet and the moon and the planet. So if the mass of the moon is m and the radius of the moon is r, then the radius of the planet will be 16r. Radius of the planet R1 will be 16r, and the mass of the planet M1, that will be equal to 144, which is 144 times the mass of the moon. Radius of the planet is 16 times the radius of that of the moon. 16 times the radius of that planet is 16 times the radius of the moon. Since the ratio of the diameter should be same as the ratio of the radii also. The escape velocity on the planet, that is v, and the escape velocity on the moon, that will be v dash. So now the escape velocity on the planet, that will be equal to root over 2 g m1 by r1. It is equal to root over. So therefore, I can say v, that will be equal to root over 2 into g into m1, that is 144 m. 44 m divided by r1, that is 16r. 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 So 6 9 0 54, 16 9 0 144. This will be equal to 3 into 2 gm by r. into 2 gm by r. So v will be equal to 3 into now 2 gm by r is the escape velocity. Okay. So therefore, the escape velocity on the moon, that is obviously root 2 gm by r. So which will be, so this is root 2 gm by r into 3, that is v. So root 2 gm by r will be v by 3. So v by 3. So option D is the correct answer. And here it is told 4 identical particles of mass m are kept at 4 corners of a square. 4 corners of a square, its mass m. If the gravitational force exerted on one of the masses by the other masses is 2 root 2 plus 1 by 32 gm square by L square. The length of the sides of the square is. The length of the sides of the square, that will be so let it be x. Length of the side of the square, let it be x. So therefore, the force on this mass will be how much? So this is force F1. This is suppose. So this will be F. This will be F1. Suppose then this will be also F. The resultant we have to find out. So F will be equal to gm square by x square, m square by L square, x square, gm square by x square. Sorry. And F1 would be equal to, this will be root 2x. F1 would be equal to gm square by root 2x whole square, that is 2x square. So now therefore the net force, net gravitational force, that will be equal to F1 plus this will become 45 degree, this will be 45 degrees. So this way I can say this will be F cos 45, F sin 45. Sorry. This will be also F sin 45, which will get cancelled, and this way it will be 2F cos 45. So this will be F1 plus 2F cos 45. So this is the net force. So F1 is gm by gm square by x square plus 2 into F, that is gm square by x square into cos 45, which is 1 by root 2. I can write it as gm square by x square. So I can write 1 by 2 plus 2 by root 2 means root 2. So this is the net force. And this is given as gm square by L square into 2 root 2 plus 1 by 32. So therefore I can say that 2 root 2 plus 1, this will be also 2 root 2 plus 1 by 2 x square. That will be equal to 3 root 2 plus 1 by 32 L square. Root 2 plus 1 will get cancelled to 16 to 32. So it means x square equal to 16 L square. It means x will be equal to 4. So the length of each side of the square is 4. So option A is the correct answer. So hope all of you understood the solutions of all these questions. Still any doubts if you have, please write that in the comments. We shall obviously clarify them. So, and please install our Sapience education application, which shall be obviously helpful for exam. So thank you everyone. Bye. So here it is told that escape velocity of a body from Earth is 7.2 km per second. The radius of the planet be 1/3 of the radius of Earth and mass be 1/6 of that of Earth. The escape velocity from the planet is. So we know that escape velocity from the Earth, that is given as over 2 gm by or I can say it is root 2 gr. So root over 2 gm by r. It means that the escape velocity is proportional to square root of the mass of the planet divided by radius of that planet. Therefore, escape velocity of the Earth divided by escape velocity in that planet, that will be equal to root over mass of Earth by the radius of Earth divided by square root of mass of the planet by radius of the planet. So it means escape velocity of the Earth, that is 11.2 km per second, divided by the escape velocity in that from the planet, that is equal to root over me by mp into root over rp by re. It's radius of the planet divided by radius of the Earth. So that is square root of mass of the Earth divided by mass is 1/6 of that hour, so it is 1/6 of me into radius of the planet is 1/3 the radius of Earth, so it is 1/3 times re divided by rp. So re will cancel, me will cancel. So from here I can say 11.2 km per second divided by escape velocity in that from that planet, that is equal to root 6 into root over 1/3. So which means that it is 1.2 km per second by escape velocity in that planet, that is root over 6/3, that is root 2. So escape velocity in that planet, that is 11.25 into km per second. So divided by root 2 means it's 1.414. It is 11.2 divided by 2. That is approximately 7.92 km per second. 7.92 km per second. So option A is the correct answer. Then here it is told the gravitational potential at a point. The gravitational potential at a point above the surface of Earth is minus 5.12 into 10 power 7 joule per kg. And the acceleration due to gravity at that point is 6.4 meter per second square. So this value is minus g m by r equal to this. Assume the mean radius of the Earth to be 6,400 kilometers, the height of this point of the Earth's surface. The height of the point of the Earth's surface that we have to find out. So this is minus g m by r plus h, that is equal to minus 5.12 into 10 power 7 joule per kg. Okay. So it means m I should not use joule by r, and g is equal to g m by, so it'll be r plus h whole square, that is 6.4. So this I can take, so that will be, it means gm I can tell, that is 6.4 into r plus h whole square. Therefore I can say 6.4 into r plus h whole square divided by r plus h, that is equal to 5.12 into 10 power 7. So r plus h will cancel. So r plus h will be equal to 5.12 into 10 power 7 divided by 6.4. Okay, so this much meters it will be. Therefore, r plus h, that is equal to 5.12 into 10 power 7 divided by 6.4. Therefore, the height, let's say to find out this much meters it is. So 10 power 8 meter, that is 1 kilometer. You can say this is 5.12 into 10 power 4 by 6.4 kilometer minus the radius of Earth, which is 7.1 kilometer. It means h is equal to, since point I can cancel out, 51200 divided by 64 minus 6,400. This much kilometer. So 488 8 fours are 32. 64 into 8 is how much? 32. 60 48, 512. 64 8s are 512, so 800 is here. So this is 6.4 actually. So we remove 1 point, this will be 1 more 0. It should be 8,000. So H should be 8,000 minus 6,400 kilometers. So this will be equal to 0, 0. So 1600 kilometers. So option A is the correct answer. When it is told a planet takes 200 days to complete one revolution around the sun, complete one revolution around the sun. If the distance of the planet from sun is reduced to 1/4 of the original distance, how many days will it take to complete one revolution? Planet takes 200 days to complete one revolution around the sun. So the time period is 200 days. If the distance of the planet from the sun is reduced to 1/4 the original distance, how many days will it take to complete one revolution? So now, when the t square is proportional to r cube, now the time period will change, means t1, when the orbital radius is r1. So r1 is the distance is reduced to 1/4 of the original distance. So when r1 is r by 4, then the time period, the new time period of evolution will be how much? One. So I can say that t1 square by t square, that is equal to r1 cube by r cube. Therefore, t1 square by 200 square, that is equal to r1 cube, that is r by 4 by r whole cube. That t1 square will be equal to 200 square into 1 by 4 whole cube. It means t1 square, that will be equal to 200 into 200 into 1 by 4 into 4 5s are 20, 5 5s are 20, and 4 25s are 100. So this is T1 square, that will be equal to 25 into 25. So therefore T1 will be equal to 25. So T1 will be 25 days. So the new time period of evolution will be 25 days. So option D is the correct answer. So here we are applying the Kepler's law of periods. It says that the square of the time period of revolution is proportional to the cube of the orbital radius of the planet around the sun. In told at distance above and below the substance of Earth, a body will have same weight. What distance above and below the Earth? So it means at a height, the value of g should be the same. Value of g will be g r square by r plus h whole square. That should be same as the g at a depth, that is given as z to 1 minus g over. But g is the value of the acceleration to the gravity at the surface. That means g r square by r plus h whole square, that should be equal to g into 1 minus g by r. So g will get cancelled. Can say that r square say r cube, that will be equal to r minus d into r plus h whole square. This will be r cube, that is equal to r minus d into r square plus h square plus 2rh. It means that r cube will be equal to r cube plus rh square plus 2r square h minus dr square minus dh square minus 2rhd. R cube will get cancelled. So we can say that 2h minus d into r square minus 2rhd plus r minus b h square is equal to 0. So here, actually we can also say g into 1 minus 2h by r, that should be equal to g into 1 minus d by r. If h is much less than r, g will cancel, then 2h by r, that will be equal to d by r. So d is equal to 2h. So if I take h as r by 2, then also it will become so the graph for g, that is actually like this. Is that the radius, the graph at r equal to r. This is for r less than r, this is at r equal to r. Actually, there will be a distance below, above and below. At h equal to r by 2, g, g by 2. At h equal to r by 2, that will be g into r square by r plus r by 2 whole square, that will be equal to g r square by 3 by 2. So this will be 9 r square by 12, 4 r square 9. Now, at h equal to root 3 minus 1 by 2 r, g at that height, that will be equal to g r square by r plus h, that is root 3 r by 2 minus r by 2 square. So this will be G R square by R by 2. So this is root 3 plus 1 by 2 whole square R square. R square will cancel. So this is 4 R square by root 3 plus 1 whole square. And the depth also, this will be G into 1 minus G, this will be G at this depth P by R. So will be G into 1 minus, so this is half plus 1 minus root 3 by 2. Plus 1 minus root 3 by 2 plus half, so this is 1 plus half, that is 3. So 3 minus 3 by 2. And this will be 4 by 3 plus 1, 4 plus 2 root 3 root G. This will be 2 by 2 plus root 3 into G. At root 5, just check the option C. So add H equal to root 5 minus 1 by 2 into R. The value of G at that height will be G R square by R plus H root 5 by 2 R plus minus R by 2 whole square. So this will be G R square by root 5 plus 1 by 2 R square. R square will cancel. So this is 4 by root 5 plus 1 whole square into G. This 4 by 5 plus 1, 6 plus 2 root 5 into G. So this is 2 by 3 plus root 5 into G. And G at the depth, that will be G into 1 minus D by R is root 5 minus 1 by 2. This will be G into 1 plus half, that is 3 minus root 5 by 2. This one, if we simplify it, this will be 2 into 3 minus root 5 by 9 minus 5, that is 4. So, yeah, so these two are same. So option C is the correct answer. Then here it is told, even below are two statements, one is labeled as assertion and another is labeled as reason. So the assertion is the angular speed of the moon in its orbit about the earth is more than the angular speed of the earth in its orbit around the sun. Angular speed of the moon in its orbit, that is omega of the moon, that is 2 pi by time period, that is it is like approximately 27 days approx. 7 days. And angular speed of the earth about the sun, that is 2 pi by t, that is 365 days time period of revolution. So it means since the time period is higher, so the angular speed of the moon, that is obviously more than the angular speed of the earth. The assertion is true. The reason is the moon takes less time to move around the earth than the time taken by the earth to move around the sun. Yeah, that is true. So that is the correct explanation of the assertion also. So it means that option A is the correct answer. Both A and R are correct. R is not. Both A and R are correct, and R is the correct explanation of A. So option C is the correct answer. Here it is told the acceleration due to gravity on the surface of the Earth is G. The acceleration due to gravity on the surface of the Earth is G. gravity on the surface of the Earth is G. If the diameter of the Earth reduces to half, so the remaining value, it means the radius changes to r by 2, and the mass remains constant. Then the acceleration due to gravity, mass of the Earth remains constant. The acceleration due to gravity on the surface of the Earth will be. Acceleration due to gravity is Gm by r square, re square, Gm by re square. Now re is changing to re by 2, so G dash will be equal to Gm e by re by 2 whole square. So this is equal to 4 Gm by re square, which is equal to 4 times of G. So it means the value of G will be 4 times. So it means option D is the correct answer. Then it is told if the radius of the Earth is reduced to 3/4 of its present value without change in its mass. If the radius of the Earth is reduced to 3/4 of its present value without change in its mass, then the value of the duration of the day of the Earth will be. Yes, the radius of the Earth is reduced to 3/4 of its present value. Radius of the Earth is reduced to 3/4 of its present value without change in its mass. So mass is remaining constant, then the duration of the day of the Earth will be this much hours. So the day the angular momentum will remain conserved. It means that pi omega that is constant. The angular momentum of rotation of the Earth will remain constant. So if you assume that the Earth is a solid sphere, so it will be 2 by 5 mass square, 2 omega, that will be constant. So it means that I can say that 2 by 5 me re square into omega square into omega, that is equal to 2 by 5 me into r dash square into omega dash. It means 2 by 5, 2 by 5 will cancel, mass will cancel, and so omega dash will be equal to re square into omega by r dash square. So this will be re square by r dash, that is 3 by 4 re square into omega. So this will be equal to 16 by 9 into omega. So omega is 2 pi by t. Omega is 2 pi by t dash, that is equal to 16 by 9 times of 2 pi by t. 2 by t will get cancelled. So then I can say that 9t, that is equal to 16t dash. So t dash will be equal to 9t by 16. So the duration of the day of the Earth. So currently the duration of the day is 24 hours. So the new duration will be 9 by 16 times of 24. So this will be equal to 16, 4, 8 to the 16, 3, 8, 24, 3, 9, 27, 27 by 2. That is equal to 2, 1, 2, 3, 6, 10.5 hours, means it is 13 hours, 30 minutes. So the duration of the day will be 13 hours, 30 minutes. So 13 is the answer. Then it is told a simple pendulum is placed at a place where its distance from the Earth's surface is equal to the radius of the Earth. If the length of the string is 4 meters, then the time period of small oscillations will be. The time period of small oscillations will be 2 pi root over L by G effective, the G dash, G at that height. The G at that height, that is given as G into R square by R plus H whole square. The so it is placed at a distance where its distance from the Earth's surface is equal to the radius of the Earth. So H is equal to R. So it will be GR square by R plus R whole square equal to GR square by 2R whole square, which is 4R square. So it will be G by 4. So the time period will be 2 pi into root over L. L is 4 by G by 4. G is pi square, so pi square by 4 into 4. So it means it will be equal to 2 pi into 4 by 5. So pi will cancel. So it was the 8 seconds. So the time period of small oscillation should be 8 seconds. So 8 is not. It is the answer. Then here it is told two identical particles, each of mass m, go around a circle. Two identical particles of mass m go around a circle of radius a under the action of their mutual gravitational attraction. Mutual gravitational attraction. They are evolving. Angular speed of each particle will be. So their mutual gravitational attraction. So we will do gm square by their distance of separation is 2a, so it's equal to 2a whole square. Gm square by 2a whole square. That is equal to gm square by 2a whole square. That is equal to force is equal to the centripetal force, which is equal to m omega square r m omega square a. Therefore, m will get cancelled, so I can say the angular speed omega only has been asked. So this omega square that is equal to gm by 4 a square into a, that is 4a cubed. So omega will be equal to root over gm by 4a, gm by 4a cubed. Option D is the correct answer. When here it is told a body is reduced from a height which is equal to the radius of the earth, height which is equal to the radius of the earth, the velocity of the body when it strikes the surface of the earth will be. So it is reduced from here. So here the uh, potential energy, so the change in potential energy that is equal to loss in potential energy that is equal to the gain in kinetic energy. So therefore I will say here the velocity is v, here the initial velocity is 0. So I will say half mv square minus 0, that is equal to the final kinetic energy minus initial kinetic energy, that is equal to the initial potential energy minus final potential energy. So it means since y loss means initial minus final, so half mv square that is equal to the initial potential energy, which is equal to minus g m by um, r plus h, that is 2r minus final value, that is minus g m by r. Since at the surface the r is equal to r, which is the distance from the center of the earth, that is equal to the radius of earth when it is at the surface of the earth. So I can say that the velocity has been asked, the velocity of the body when it strikes something there. So mass I can cancel, mass of the object, and then so v square by 2, that is equal to gm by r minus gm by 2r. It means v square by 2, that is equal to gm by 2r. Since gm by r into 1 minus half, that is half. So 2 will get cancelled, so v is equal to root gm by r. Gm by r. So this, you know that Gm by r square that is equal to G. So Gm is equal to Gr square by r that is equal to root Gr. So option D is the correct answer. So hope all of you have understood the solutions of all these questions. Still any doubts if you have, please write that in the comments section. So thank you everyone.